good. Why is everyone coming in on you? There we go. One day, it will say dp over dt. I'm going to keep rambling, and eventually it'll show up. So the nice thing, remember, about Leibniz notation is that it kind of just falls out the units for you in a way. So if it's dp over dt, the units of p are people, and the units of t is in years. So it'll be in people per year. I hate this so much. I just want to take a nap. Usually I would unshare and reshare to fix it, but y'all saw what happened last time. I don't want to do it again. One moment, please. And there it goes, of course. Why are the things that I need not in my bag? Beautiful. All right, cool. People per year. Interpret f of 10 equals 220 and f prime of 10 is 15. Well, now I can't see the chat. I got this. So remember, the f of 10 being 220 is just a normal function statement. It's not a derivative at all, so we don't need any of that fancy derivative hoopla. So we would just say this is 10 years since 2000, 220 people. So in 2010, the town has a population of 220 people. Why haven't I always plugged in my laptop like this? This is gorgeous. Chat. There we go. Okay, cool. And now I'm choking. All right, f of 10, f prime of 10 being 15, so that's our derivative statement, so that's a slope. So we need to choose between either the right way or the step way. I find most people usually do the right way, so I'm going to go ahead and write that. So after 2010, the population is increasing by 15 people per year. If you went the step way, it would have been something like after 2010, for each additional year, the population increases by 15 people. So remember, the difference, one of the main differences between the two is kind of the units that you tack onto the 15. One of them, since it's written as a rate, oh, people on Teams, it's still super lagging for you, isn't it? I got to keep track of that. All right, sorry. So it's no longer lagging for you guys, but it's still lagging for Teams people. So we're still going to have to sit around and stare at each other for a little bit. What was I saying? If you went the step way after 2010, for each additional year, population increased by 15 people. So remember, there's kind of that unit difference between the two. Oh, my Lord. Come on. There we go. Magic. I can't. Can't handle it. All right. So now that that's been up for a couple seconds for the Teams people. Teams, I assume that at least some of your screens are lagging as much as mine is, so that's why I'm waiting so long, even if some of you might see it. But anyway, now we want to estimate f of 20 and f of 5. So that's where we have 10 and f prime of 10, and that's the only things we have to use. I'm very scared of doing this. I'm terrified. You'll see it, but maybe the, oh, thank God. Okay. Why did I put 20? So all we have to use, Kern and Lauren, did that help? Yes? Okay, cool. Sorry, so all we have is f of 10 and f prime of 10. So remember that f prime is essentially telling you if you go over 1, how many you increase by. So if we want to get from 10 to 20, well, we have to start at 10. We want to take a couple steps to get to 20. So how many steps do we have to take? We have to take 10 of them. The difference between 10 and 20 is 10. So that's why we have to multiply that value by 10. So we have 220. Teams, it's lagging really bad. There we go. Magic. We have 220 plus 10 times 15. So 220 plus 150 equals 370, if I'm remembering correctly. Yeah, 370. All you see is a black screen. Y'all can't see I don't have to cheat, right? That's how it works. Okay. Let me try sharing one more time. Guys, I'm not kidding people on Teams. Teams has been my worst enemy today. I wasn't able to teach in my last class at all because of it. Oh, Caitlin, now I have the black screen of death. Okay, let's try one more time. Now y'all can't see what I'm talking about because I put my laptop up. You can't see the terribleness that is that. Okay, it's up on my screen, Caitlin. Can you see it? Maybe, hopefully, possibly? Please, dear Teams gods. Hooray! Okay. Questions on anything I've done so far? Okay, cool. F of 5. We still have to start at f of 10 because that's the only thing we're originally given. And I need to use f prime of 10. But now I need to figure out how many steps I need to take. Well, the difference between, you always want to do what you want versus what you have. So there's a difference of -5. So we actually have to multiply that value by -5. So, well, you could add -5 if you wanted to, but that's the same as subtracting. So I usually don't write it. So we'll have 220. 5 times 15, if I'm remembering correctly, it was 75. Oh, don't you dare. Stop working, pen. Thank you. Oh, well, I wrote it like this before. Hold on. So 220 minus 75, I think. I'm going off of memory from my last class. There's a 145. That magically is already caught up to me, so that's good. Questions, concerns about that first question?
Why did you subtract instead of add, like the first one?
Right. So you have to think about the fact that like what we have to start with is at 10. And what I wanted to get to was 5, which is kind of, backwards from 10. So you also need to take into consideration not only how far apart they are, but kind of what direction it's in. If it's greater than 10, then you add it. If it's less than 10, then you have to subtract off the value. So since there's kind of a difference between 5 and 10 of 5, but it's, less than 10, we had to subtract it instead of adding it. Where did the 15 come from? That was given to us up here. So I'm just pulling this derivative value from what I was given in another part part of the question. Yep. Any more questions? Okay, cool. Next one. It worked. Anyway. Oh no, my little arrow didn't move down. So here we were given an original function and we wanted to find the correct derivative graph from it. So remember, from here we want to essentially point out where the maxes and mins are of this function. So we have one at -2, at 1, and at 3. So for the derivative graph, so this is the original. So for the derivative graph, that would mean that the derivative would have to cross the x-axis at those 3 points and only those 3 points. This one down here crosses correctly at -2, but then does not cross at 1 and doesn't really cross at 3 either. Maybe you want to give that the benefit of the doubt, but really you can't, because -1 is positive 1 isn't getting crossed at. So this one is definitely not it. Oh my god, it keeps doing it exactly when I do that. That's cool. Anyway, so it's not that bottom option because it crosses 3 times but not in the right spots. So we're down between these top two. So that's when you have to look at the increasing, decreasing piece. So my original function is decreasing, and then increasing, and then decreasing, and increasing. So that means that my derivative, I'm looking for it to be negative, and then positive, and then negative, and then positive. And remember, when I say positive and negative, I mean above versus below the x-axis. I didn't need to throw that. There we go. So we're looking for something that starts out below the x-axis, then goes above, below, and above. The only one of the last two options that does that, I want it to start out below the x-axis, so that would be our first option here. Essentially, the second option is kind of, it crosses at the right spots, but it's the opposite order that we needed it to be in. Questions, concerns on that one? We got 15 minutes, so we'll kind of start 2-5. Maybe, if, you know, the technology wants to work. All right. So let's see if I can jump over to 2-5. Maybe. Cool. No, that's not right. There we go. Okay, teams, let me know if you can't see 2-5. I'll give you a couple seconds to let me know before I start rambling. I can see it on my screen, so hopefully y'all can see it on your screen. Oh my god, stop. All right, looks like we're good. All right, so we finished 2-4 the other day, that really short one about the second derivative. Oh man, I meant to look at your homework. I'll do that for Friday. Anyway, so 2-5 is about marginal cost and revenue. Now, we've already slightly talked about this before, but we're kind of going to go into a bit more depth here. So up to this point in time, we've only discussed linear cost, revenue, and profit functions, but they don't need to be linear. They can be any type of function they want to be. And so in those cases, we can still talk about marginal and fixed costs, or revenue, or profit. So specifically, considering just the cost function, this does transfer over to either of the other two options. But let's just focus in on cost for a second for our sanity. So specifically considering cost, the y-intercept, oh, that's really, why is that so thick? There we go. So the y-intercept is going to be the fixed cost. Now I will say you usually, maybe I'll make a little side note. I'm going to say don't have, but I'm going to put it in quotes because you technically have it, we just don't really talk about it. Fixed revenue or profit. If you want to get technical, you have them because there are y-intercepts for that function. but you pretty much never refer to them as fixed revenue and fixed profit. It's really just cost that has the fixed aspect to it. But in terms of marginal, that's the one that kind of matters a bit more. That definitely covers the gambit of all three: marginal revenue, marginal cost, marginal profit. So that's regardless of the equation. Whatever your y-intercept is, no matter if it's linear or otherwise, is going to be your fixed cost. And then the slope is going to be the marginal cost. Now, we kind of already knew that when we were talking about linear, but if you don't have a linear function, how can you talk about the slope? Well, we just started figuring out this thing called the derivative that tells us slope. So we can find the slope or the marginal cost or marginal revenue or marginal profit of absolutely any function by using the derivative. I'm waiting for the team's one to catch up to me. Here we go. So now that we have this notion of the derivative, we're going to be able to talk about the slope of absolutely any function. And specifically also, probably we'll start on Friday based off of how much we've covered so far, but definitely next week we'll be talking about derivative rules to just find the equation of a derivative. We'll be able to talk about it in more detail because we'll actually be able to find the exact derivative that we need. So, scroll down a little bit. There. Okay. So if we have the cost and revenue functions graphed in this graph, so, oh God, the straight line is revenue. So this one's the linear one because that's a little hard to see. And then the curvy guy is the cost one. So what production values does the firm actually make profit? Well, if you think about it, this isn't really even talking about marginal yet. But remember, profit was equal to revenue minus cost. So if we want that to be, positive, we'd want revenue minus cost to be positive. Let me pause for the team screen to catch up to me. Go. A little awkward dance because I never know what to do in these situations. Oh, come on, teams. You got this. You can do it. I believe in you. How y'all doing? Oh, come on. Really? We'll do it all right. Having a good time? I'm not. Thank you, Lord Almighty. So if we want profit to be 0, then revenue minus cost must be positive. Sorry, not 0. Positive, greater than 0. Add over C to the other side. And now my pen's not drawing. Oh my God. What is happening? I just want to do this one example. If you let me do this one example, I'll just stop and then it will be done. I promise. Just let me finish it. Oh, Lord, thank you. So then revenue must be greater than cost once teams catches up to me. Oh, so close. Draw the C. Yeah, I'm so sorry. But I'm also not sorry because it's not really my fault. But I am sorry that it's just obnoxious. Teams. There's a C on the other side of that greater sign, teams. It'll pop up eventually. So we essentially want to look at this graph and find out where revenue is greater than cost. When is the revenue function higher than the cost function? The only spot that that's going to happen in is kind of this middle section here, which I've boxed which you'll see in about 5 years, teams. Because since the linear function, the straight line is revenue, the only time that it essentially is above, has a larger y value than that curvy one, is kind of in that middle piece. So we would say that revenue is equal to cost, sorry, greater than cost. Now I can't even talk. Revenue is greater than cost, so they were nice and kind of put these lines here for us. So we would say that revenue is greater than cost. Oh, I should be super careful. Between 130 and 215. It's slowly catching up to me, teams. And I'll write it like this. Revenue is greater than cost for Q in that interval. Oh, come on, teams. I'm going to do the horrible thing. Hopefully things don't blow up. Black screen of death. There we go. So, just to wrap up one more time, especially for the people on teams who are now just seeing all of that written out for the first time. So we wanted revenue to be greater than cost because we wanted profit to be positive. So if profit is positive, revenue minus cost is positive. That must mean that the cost is smaller than the revenue, which only happens in that kind of middle section that's kind of boxed on that function. So I would say that revenue is greater than cost for Q in that interval. I know it looks like a point because it's parentheses, but that's an interval from 130 to 215. Now, I didn't include 130 and 215 because at those points, the functions are equal. And so we'd have profit being 0. Those would be our break-even points. And I don't want 0 profit. I wanted positive profit. So I don't want to include them. So I don't want that to be brackets. I want them to be parentheses. Your screen is black still? I think if you wait for a couple minutes, it might come back, but let me try unsharing and resharing really quick. I'm not going to do any more. I'm fed up. So I'm going to stop after this anyway, but I'll try to reshare it so you can see it. Black screen of death, black screen of death, black screen of death. It popped up for me. Hyper, maybe. Nope. Okay. Well, we didn't get that far. So, just glance on Blackboard really quick later today. We didn't cover a lot, guys. Who can't see this? We only did that one small example. I don't know why Teams is being the biggest jerk in the world today. But just hop on Blackboard later today. I'm really sorry. I don't know how to fix it. And we're just gonna go and take our quiz because I can't. I don't want to. I don't wanna. So I gotta make that pop up for you guys on Teams. Well, on Blackboard. It's not up on Blackboard yet. Oh Lord. So we're a couple minutes early for it, but again, I don't care. I don't.